we want to talk about discrete and continuous variables. Okay, discrete and continuous random variables. So a discrete random variable is going to be countable. Okay, it's going to be countable. A continuous random variable is going to be measurable. So if you want to think about that in a different way, you can count things, and it's kind of, I can count how many students are in my class. So it would be not advisable to have 1.5 students. Okay, so I could say I've got 1 student, 2 students, 3 students, 4 students, and so on. But to have 5.5 students, that's not a possibility. Okay, so that's going to be discrete. It is countable. So an example of a measurable or continuous means that those intermediary fractions and decimals are possible. So if we're talking about time waiting at a doctor's office, then I could say, all right, I was there, I waited for 2 hours, or I waited for 2.5 hours, or I waited for 2.25 hours, and I can keep breaking that down. And so those little fractional portions are acceptable to use. So that's going to be continuous. So discrete is countable and continuous is measurable. All right. So let's focus on some discrete probability functions. Okay, and a couple of things that we have to have as conditions. One of them is that your function needs to be greater than or equal to 0. Your function needs to be greater than or equal to 0, and the sum of every function needs to add up to 1. In other words, the sum of the probabilities need to equal to 1. So what does this mean? It means you're not going to have anything negative. I don't know why I put that equal sign there. Okay, it means you're not going to have anything negative because you want everything bigger than 0. But your probabilities are going to be anything bigger than 0. When you add up all of those probabilities, so this symbol means it's a Greek capital letter of sigma, and it means added them together. Okay, so when I see sigma, that means add it all together. So when I add up all of these little portions, they all need to add up to 1. So remember that 1 is the same thing as if I divide, I'll end up with 100%. So we recognize that 1 is the exact same thing as 100%. So the sum of all the probabilities need to be 100%, but we leave it in decimal form. So we can have a discrete uniform probability function. So a uniform probability function means that all of the outcomes are going probability. All outcomes have the same probability. Have the same probability. So something that is used in the textbook and something that is that we always use for probability is rolling a die. Okay, so rolling a die means I can get a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of rolling a 1 occurs once out of 6 times. The probability of rolling a 2 occurs once out of 6 times. The probability of rolling a 3 occurs once out of 6 times. So your uniform probability distribution simply means that all of the outcomes have the same probability of occurring. All of the outcomes have the same probability of occurring. So the easiest way for us to represent that is how many outcomes are there? There's 6. And each one has the same level of probability. So each one is going to be 1 out of that number. So what we use to represent that is 1 out of n. And that's uniform. Okay, everything has the same probability of occurring. We could also use something that is not uniform. Okay, so another example from our textbook is selling automobiles. Okay, so selling cars, because we don't call them automobiles. All right, so I could say the probability of X. So I could say selling 1 car, 2 car, 3 car, 4 car, 5 car. What's the probability of selling no cars in a day? Okay, what's the probability of selling 1 car in a day? What's the probability of selling 2 cars in a day? So again, this is discrete because I'm going to count cars. I'm not going to measure cars. And then I can assign different probabilities to that. So just taking it straight from the textbook, what does this mean? This means that the probability of selling no cars at all is 18%, but we're going to leave that in decimal form. The probability of selling 1 car is 39%. So I didn't change it to continuous. Even though these are decimal representations, my variable itself remains discrete. But this time it's not a uniform distribution. Okay, so I've got 24, 14, 04. So 24, 14, 04, and 01. Okay, and when I add all that together, I get 1. So the probability of selling no cars, 1 cars, 2 car, 3 car, 4 car, 5 car is all represented over here. It is still a discrete variable. It is no longer a, it's not a uniform distribution because these values are not the same for each outcome, for each possible outcome. So it is not a uniform distribution. Okay,